We will proceed to discuss rest of the option now. The next input that comes is flood fill after completion input, which is again a tick input that is available here. Flood fill is a separate operation available in edit mesh option. This operation sorts the volume elements according to material points and puts them in their respective volume paths. This operation is recommended if there are multiple material points. Here this option is integrated with Delaunay algorithm if enabled flood fill operation is performed after mesh is computed. If required, material points can be changed or defined after mesh is computed and only flood fill operation to put volume elements to appropriate path. As an example here, this geometry consists of three intersecting spheres. This creates 5 volumes, that is 1, 2, 3, 4 and 5. Initially, no material point is defined, so all volume elements are put in same part. So this is how the mesh is created if all the volume is a single material point or a single part. Now, once we create 5 material points or define 5 material points and then flood operation is performed, flood puts volume element to different parts as specified by material points, as you can see here. Next option is verbose output. Now let us see the T-grid option. T-grid 11.0 is a mesh method that is available as beta feature in ICM. It is still a development stage and can be accessed by enabling beta functions. This is available here. If we go to mesh, then global mesh setup, then volume meshing parameters, and after that we select the mesh type and then we select the mesh method, which is T-grid 11.0. This creates smooth volume mesh than the Delaunay and advancing front. Also, computation time for mesh creation is less than the Delaunay and advancing front method. As this is a beta feature, more information is not available. Options available in T-grid 11.0 like expansion factor, flood fill, verbose output are same as discussed before. The ATF scheme is advancing front tetrahedron scheme. So just the new thing that is available within the T-grid option is use ATF scheme. Now let us discuss the compute mesh procedure. After setting all the volume mesh parameters as we discussed in the earlier slides, final step is to compute the mesh or create the mesh. Compute volume mesh option can be accessed by going to mesh, then compute mesh, and then we go to compute volume mesh. Mesh method and mesh types can also be changed in the compute volume mesh tab. These figures show different options available in compute volume mesh tab depending on the mesh method selected. Most of the options are common and will be discussed in the next slide. First among the options is create prism layers. This option is available for all mesh methods. It creates prism layers as per the parameters specified after volume mesh is computed. If user enables this option, then intermediate volume mesh, that is mesh without prism, will not be saved, and if some changes in prism are to be made, then volume mesh has to be created again. So we have to be careful with this create prism layers. Prism layers will be discussed in details in the next lecture of this series. The next option that we will discuss here is the create hexacore. This option is available only for octree and Delaunay method. This creates hexacore mesh, but it is not recommended to use this option as hexacore mesh can be created by using merge tetra option available in edit mesh tab. Now we will discuss inputs that are required for creating volume mesh. Either geometry or surface mesh can be used as input for creating volume mesh. Input options available for Delaunay and AF schemes are same. So we will discuss them one by one. First is the geometry selection. We can select all geometry that is available for mesh creation. If we select existing mesh, only existing mesh is selected as input to create volume mesh. If we select part by part, this allows the user to select parts which are to be used as input for creating volume mesh. There is another option called from file, that is .uns file. If surface mesh is already created, then it is saved as .uns file and this can be selected as input. This saves time as it is not necessary to open the surface mesh file to create volume mesh. Now let us discuss the inputs that are required for the octree method. Combination of geometry and surface mesh can be selected as input for octree method. Options available in geometry selection are all visible, part by part and from file. From file input option .tin file can be selected as geometry input. Use existing mesh parts option allows user to select mesh parts which are to be selected as input for volume mesh. Now we are coming to the end of this particular lecture, and what we will do is we will compare all the three methods, that is octree, Delaunay and AF. We will use the geometry of an aeroplane that is meshed with similar sizing to compare the effects of different meshing schemes. This particular mesh is created using Octree method, the middle one is created using Delaunay method, and the last one is created using advancing front method. Now we will discuss one by one the advantages of Octree method. Octree is a very robust method. Patch independent also uses Octree scheme. So if patch independent is selected for surface meshing and Octree for volume meshing, then time required for mesh creation can be saved. Main advantage of Octree is that mesh ignores small features like patches, holes, etc. This greatly reduces the geometry cleanup required. Density function works very well with the Octree method. But Octree method also comes with disadvantages. First is that computational resources required are very high as compared to other method. Time required for mesh creation is more than the Delaunay and AF methods. Cell count of mesh created by Octree is high, which increases simulation time later. Due to Octree methodology, mesh transition is not smooth. Now the middle mesh, which is created by Delaunay, some of the advantages of the Delaunay scheme is that Delaunay is the fastest method available in ICM. Unlike Octree method, growth rate can be specified in the Delaunay scheme, which creates smoother transition in mesh. Cell count of Delaunay is less than Octree. Delaunay scheme also has some disadvantages, like surface mesh is required for creating volume mesh. If it is not present, then it will be created using parameters specified in global mesh setup, which again increases time for meshing. Delaunay algorithm is not as robust as the Octree method. Minor defects in surface will result in failure of meshing algorithm, and user have to create them before proceeding further. The last mesh that is created is by using the advancing front method. The advantages of this advancing front is that it produces more smooth mesh than Delaunay, as volume mesh is created layer by layer. Mesh count is less than the Octree method but more than Delaunay method. The disadvantage of the AF method is same as those that are there for the Delaunay method. So by this we come at the end of this particular lecture. Thank you for viewing this lecture on volume meshing. After this we will progress to prism layer meshing, which is the next lecture in the series of ICM meshing lectures. So see you in the next lecture. Thank you.